All right, so today we're going to talk about Chapter 6, Section 2, Trigonometric Functions, a Unit Circle Approach. So when we talk about the unit circle, we're talking about a circle centered at the origin with a radius of 1. So if you look at the 4 points on your unit circle, that would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Any point P is going to be an x coordinate and a y coordinate, and any line S is going to be a certain, any point from tangent to the circle to T is going to be T units long. And then if you do that same distance T from this point tangent to the circle to T, it's also going to have a distance of absolute value T units long. If we look, this could be also represented by an arc length. So if we bent this distance along our circle, our arc length would be P units. All right, so if we let T be a real number and any point P be x comma y, be the point on the unit circle that corresponds to T, the sine function associates with T the y coordinate of P and is sine T equals y. So your y coordinate is equal to sine T. The cosine function associates with T the x coordinate of P and is cosine T equals x. So x is equal to the cosine T. And if x does not equal 0, then the tangent function is the ratio of the y coordinate to the x coordinate, and it's y over x. We're going to now deal with our cofunctions. So once again, if we're using P as x comma y, as long as y is not equal to 0, the cosecant of T is equal to 1 over y. As long as x is not equal to 0, the secant of T is equal to 1 over x. And as long as y is not equal to 0, the cotangent is x over y. All right, so for our first learning objective, we're going to find the exact values of the trigonometric functions using a point on the circle. Remember, exact values means not the decimal approximation, but the fraction or the root. Okay, so if we want to find sine, cosine, tan, cosecant, secant, and cotangent of T. If the point is negative 1/2, comma, root 3 over 2, so we're going to use each of those. If you remember, sine T is equal to y. So if we graphed it, it would look like this. T is our arc, and it lands us at negative 1/2, comma, root 3 over 2. So the sine of T is equal to, they have changed it to V, and it's really just y. So it's equal to our y coordinate. Okay, and then if you remember, looking back at your equation, the cosine of T is the x coordinate, which for us is negative 1/2. The tan is y over x. I remember that because it's like rise over run. So that's the y coordinate over the x coordinate. So that's root 3 over 2 divided by negative 1/2. And remember, dividing by a fraction is the same as multiplying by the reciprocal. So we're taking the root 3 over 2 and multiplying it by negative 2 over 1. 2's cancel out, and I'm left with negative root 3. Then we have our cofunctions. The cosecant of t is equal to 1 over the y coordinate. So that's 1 over root 3 over 2. 1 times the reciprocal of root 3 over 2. So we get 2 over root 3. And we can't have root 3 in the denominator. Remember that as your inputting answers in your quizzes. So we multiply the top and the bottom by root 3 to get 2 root 3 over 3. The secant is 1 over the x coordinate, so that's 1 over negative 1/2, or 1 times negative 2 over 1. And then the cotangent is the opposite of this. It's negative 1/2 over root 3 over 2. Negative 1 over root 3, and we can't have the root 3 in the denominator, so we multiply by top and bottom by root 3. One thing to note, your cofunctions are, if you look at the sine and the cosecant, I could have just taken the sine and flipped it to get the cosecant, because these guys are buddies together. The cosecant is 1 over the sine, so. And then for the cosine, I could take the secant and flip it to get, or the cosine and flip it to get the secant. So these are related in the same way. So sine is buddies with cosecant, cosine is buddies with secant, and cotangent and tangent. Thankfully, those go together. I always have to remember it's opposite. I always expect sine to go with cosecant because the cos are buddies, but they don't go together. Only cotangent and tangent go together. Okay. Oops. So if I'm talking angles, so we have our unit circle centered on the origin. We have arc length t. We're going to start talking about this theta to give us a little idea of where our point on our unit circle is going to be. So we've stopped talking about this point as x comma y, and we're talking about it as a comma b now. So if I have a arc length of t, then I am t radians. That's what my theta is going to be. It's the same as t radians. So now we're going to redefine all those values using radians. So if theta equals t radians, the 6 trigonometric functions of the angle theta are defined as sine theta equals sine t. So they're just taking out the theta and putting in, or the t and putting in theta, because we want to talk about things in terms of radians like we talked about yesterday. So this just gets all of our functions in terms of radians. All right. We're going to find the exact values of the trigonometric functions of quadrantial angles. So when theta equals 0, that's equal to 0 degrees. So we are on that right-hand side. We're on the x-axis. We're 1 unit out. Right here. So when theta equals 0, we're on that unit circle, 1 unit out. Our a value, our x value is 1, and our b value is 0. So the sine is 0 over 1. And you can think about it like Actually, let's go ahead and highlight the pause. Okay, so the sine of 0 degrees is 0 over 1, or 0. The cosine of 0 degrees, this a coordinate is 1, and the radius is 1, so the cosine of 0 is 1. Tangent is 0 over 1, and the secant is 1 over 1, or 1. Since my y-coordinate is 0, cosecant and cotangent are not defined because they make us divide by 0. Totally not allowed. All right, so if I want to find the exact values for sine, cosine, tan, cosecant, secant, and cotangent for theta equals pi over 2, or 90 degrees. So my unit circle for that. 90 degrees has a coordinate of 0, 1. So that for sine, we would get the y-coordinate over the radius, or 1. For cosine, we would get 0 over the radius. 0 over 1 is 0. For cosecant, I would get the radius, which is 1, over b, which is 1. And the cotangent would be a over b, or 0 over 1, which is 0. Since the x-coordinate is 0, that makes tan of pi over 2 and secant of pi over 2 as not defined, so we don't include those. All right, so we did 0, we did 90 degrees, now we're going to do 180. Those are the quadrants. So that's over here at -1, 0. So we get a sine of 180 is 0, cosine of 180 is -1, tangent of 180 is 0, and secant of 180 is -1. And then the cofunctions for sine and tan, which are cosecant and cotangent, are not defined because they are 1 over that value, and 1 over 0 is not defined. Okay, what's next? 180 then. We did 0, 90, 180. 270. Okay, or that's 3 pi over 2. So we're going all the way around the circle. That's at the coordinate of 0, -1. So that means our sine of 3 pi over 2 is -1. Cosine is 0. Cosecant is -1. Cotangent of 3 pi over 2 is 0. And then the cofunctions for cosine, which is the secant, is not defined because 1 over 0 is undefined. And then the tangent is undefined because our x-coordinate, which it's y over x, is 0, and that is not defined. All right, so this is an important little chart. This chart will help you, so highlight or write it down or star or double box. You're going to need this chart. It's a good reference. We're actually going to add more to it, but for right now, these 4 points on your unit circle are going to help you give your answers. All right, so now we're going to start outputting answers. The sine of 3 pi. How long does it take to get around the unit circle? How many pi's to go all the way around? 2 pi. Because what's the circumference of a circle? 2 pi r. So that's why if you're talking totally, I just go back. Okay, circumference, because we're going all the way around the circle. That's like the circumference. So what's the circumference of a circle? 2 pi r. And if our r is 1, we go with just 2 pi. So 3 pi gets us, it only takes 2 pi's to get all the way around the circle. So if we subtract out 2 pi's, we're left with just 1 pi. So 3 pi's goes all the way around the circle, and then 1 more pi. So it's over here at, so we look at our chart, the sign of pi is 0. Cosine of negative 270, negative means we go clockwise. We start at standard position, we go around 180, 270 brings us to 90 degrees. So cosine of, we look at our chart, cosine of 90 degrees is 0, because it is the x-coordinate over the radius, which is 1, 0 over 1. All right, now we're dealing with pi over 4. He's a tricky little piece, but he's okay. Tangent is always 1. Beautiful. So pi over 4 is the same as 45 degrees. Let's look at him on our unit circle. We know information about our 45 degree angle. When we have a right triangle, we know 45, 45, 90. All right. So the line that goes through the point where theta equals pi over 4 is y equals x. If we use Pythagorean theorem, x squared plus y squared equals 1. And then we use the property that y equals x. So we got x squared plus x squared equals 1. 2x squared equals 1. X is equal to 1 over root 2. That looks a little bit familiar. And then root 2, we have to rationalize the denominator, so we multiply that by square root of 2. And then we get y and x both equal root 2 over 2. So if we know that at pi over 4, our point on our unit circle is root 2 over 2, comma root 2 over 2, we can put the 4 trigonometric functions together. So the sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. Tangent of pi over 4 is root 2 over 2 divided by root 2 over 2, which is 1. Cosecant of pi over 4 is root 2, so it's 1 over root 2 over 2. So that's 1 times 2 divided by the square root of 2. Rationalize that denominator, you just get square root of 2. Secant is the same thing, square root of 2, and cotangent is also 1. Okay, so now we're going to start messing around with those. I start multiplying them together, and you're really going to have to engage your algebra brain because it's going to keep track of positives and negatives. We have to rationalize denominators. We have to multiply fractions together. So engaging the two skills. So the sine of 45 degrees times the tangent of 45 degrees. Sine is root 2 over 2. Tangent is 1, so that would be root 2 over 2. The secant of pi over 4 times the cotangent of pi over 4 is root 2 times 1, or just root 2. All right, now we're going to deal with pi over 6 and pi over 3, which are 30 and 60 degrees. So if we draw our triangle where we have 30 degrees, 60 degrees, we have a leg and a hypotenuse of 1. we're going to think about this as a 30, 60, 90 triangle, where A is our short side, B is our long side, and C is our hypotenuse. And if we make a congruent triangle, we can kind of put together two sides. We know I did this a little bit differently. I would have gone 30, 60, 90 triangles. But the way this stands now, this is an equilateral triangle. We know that 2A is equal to 1, so A is equal to 1/2. I would have gone 30, 60, 90, where your short side is A, your long side is A times root 3, and then this is 2 times A is equal to 1. This way works as well. So 2A, since it's an equilateral triangle, 2A is equal to 1, so A is equal to 1/2. We can use Pythagorean theorem to find B. 1/2 squared is 1/4, plus B squared. 1 squared is 1. We subtract 1/4 from both sides. B squared is equal to 3/4. We take the square root of both sides to get B, and B is equal to root 3 over 2, because the square root of 3 is, square root of 3, and the square root of 4 is 2. So now that we have these values, we can say our x coordinate, or our a value, is 1/2, and our y coordinate, or our b value, is root 3 over 2, when theta equals pi over 3. So for pi over 3, 60 degrees, we have this coordinate 1/2 comma root 3 over 2. The sine is the same as the y coordinate. The cosine is the same as the x coordinate. The cosecant is 1 over the sine. Rationalize that denominator, you get 2 root 3 over 3. The secant is the same as 1 over 1/2, which is 2. The tangent is the sine over the cosine. When you multiply root 3 over 2 by 2 over 1, you get root 3. And the cotangent is 1/2 divided by root 3 over 2. We multiply that by 2 over root 3. The 2's cancel, and we have 1 over root 3. And we multiply by root 3 over root 3 to get root 3 over 3. We are going to switch it up for pi over 3. So for pi over 3, we tilt that triangle that we were dealing with before on its side so that the 30 degrees is here, 60 degrees is here. So this, our x coordinate, becomes the root 3 over 2, and our y coordinate becomes the 1/2. It doesn't change the exact values, it just puts them an opposite, where what we had for 60 degrees for sine will now be our cosine for our 30 degrees. So same things, just different. Assigning it to sine is 1/2. Cosine is root 3 over 2. So these switch, when these are switched on 60 degrees. Cosecant of pi over 6 is 2. Secant of pi over 6 is 2 root 3 over 3. Tangent of pi over 6 is root 3 over 3. And cotangent of pi over 6 is root 3. And the chart for those, I promise you, writing this chart down is well worth it, because instead of having to hunt and peck, having it in one spot, knowing, oh yeah, I wrote this down, it will take you seconds to use the chart versus trying to look it up. And your calculator is not going to give you an exact answer. So. All right, so let's look at a sample problem. We have a rain gutter that's going to be made from an aluminum sheet 12 inches wide. We mark off 4 inches from each end, so we've got three 4-inch segments. The length is bent up at an angle of theta, and the area A of the opening is this function here. The area as a function of theta is 16 sine theta times cosine theta plus 1. Find the area for theta equal 30, theta equal 45, and theta equal 60 degrees. So we're going to take our formula and we're going to deal with the 30 degrees first. So we're going to plug 30 degrees into our function and then find the sine of 30, cosine of 30. So the sine of 30 is 1/2, cosine of 30 is root 3 over 2. 16 times 1/2 is 8. Root 3 over 2 times 8 is 4 root 3. And 8 times 1 is 8. So the first area is approximately 14.93. This? 16 sine 30. All right, so the opening for theta equals 30 is about 14.93 square inches. We're going to do the same thing for 45. I know that the sine of 45 is root 2 over 2. Cosine of 45 is root 2 over 2 as well. If I multiply everything together, we get 8 plus 8 root 2, which is approximately 19.31. So the area of the opening for theta equals 45 degrees is about 19.31 square inches. We'll do that lastly for 60 degrees. So we're really bending that up there. When we do the math on that, sine of 60 is root 3 over 2. Cosine 60 is 1/2. We get 12 root 3 or 20.78. So when theta equals 60, it is about 20.78 square inches. Okay, so we're talking about integer multiples of pi over 6, pi over 4, and pi over 3. An integer is a positive or negative whole number, just to remind y'all. So when we look at it here, this is pi over 4. This is 3 pi over 4. This is 5 pi over 4. And this is 7 pi over 4. The coordinates change depending upon which quadrant you're in. My root 2 over 2, comma root 2 over 2 become negative root 2 over 2, comma root 2 over 2 when I'm in the second quadrant. They both become negative when I'm in the third quadrant. And the y coordinate is negative when I'm in the fourth quadrant. So knowing where you are in the quadrant, you get the same answer, but it might just be positive or negative. So cosine of 135 corresponds to 35 degrees. That's actually 45. Corresponds to 45 degrees. This is wrong. This should be a 4. So when you look at 45 degrees, that's root 2 over 2. We're talking cosine is root 2 over 2. We go to the second quadrant. Our x-coordinate is negative, so that means our cosine is going to be negative since cosine is our x-coordinate. So for 3 pi over 4, so here's pi over 4. Here's 2 pi over 4. 3 pi over 4 is right here. We want the tangent, which is root 2 over 2 divided by negative root 2 over 2. So that is negative 1. 225, well 180 is right here. And 45 degrees more is this coordinate right here. That gets us to negative root 2 over 2, negative root 2 over 2. So when the point is both negative, we just want to look at the y-coordinate for sine. So the sine of 225 is negative root 2 over 2. For D, negative 5 pi over 4. So here's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. But it's negative, so we have to go backwards. Pi over 4, so negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4. So it's actually right here. Cosine of negative 5 pi over 4. So cosine is our x-coordinate, so that's negative root 2 over 2. And then last, 9 pi over 4. So if I count pi over 4s, that's pi over 4, 2, 3, 4, 5, 6, 7, 8 pi over 4, 9 pi over 4. So that is the sine is the y-coordinate. That's root 2 over 2.